Hello, in this video I'm going to solve question number 6 from this old national exam. Determine f prime when f of x is 4 cubed minus 12x. Part B, f of x is equal ax squared minus 4 over x. And finally C, f of x is 1 over 3 to the power of minus 2x. That would be a good idea if you pause the video at this point and give it a try. Okay, so let us try to solve the problem. So if you don't mind, let me bring the part of the formula sheet which is relevant to this part, and that is called function derivative in the formula sheet. This is just a copy and paste or a screenshot from that part of the formula sheet which is relevant, and of course in the national exam it is always available to you. Okay, so the first part I want to differentiate. I'm sure that majority of you exactly know what the answer is, and if you know that, just please write the answer immediately here. But let me try to explain it in more details. So if I want to calculate the derivative of the function f in part A, it means that this is my function, I have to differentiate it. But then if I have the sum or difference of two functions, I can break it into two parts. I can say that the derivative of the first part minus the derivative of the second part. This is due to this formula, but of course for the minus sign. Okay, but now I want to use this part of the formula sheet because that's a multiplicative constant. That's also a multiplicative constant. This row will tell me if you want to take the derivative of this combination, don't do anything with the constant, just take the derivative of your function and multiply them. So I will do the same thing. So I pull 4 out and just take the derivative of x cubed. There I pull 12 out and just take the derivative of x. But the derivative of x cubed and x can be calculated using this formula. So you see that in this formula, n goes down and this is subtracted. 1 unit is subtracted from the exponent. So this means that I will have 4, then it becomes 3x squared, and then minus 12. The derivative of x is also simply 1. Yes? But 4 times 3 is 12x squared minus 12. And I am 100% sure that you are able to come from here to here directly, and that is the answer that you are supposed to write here, 12x squared minus 2. The reason I wrote all of these things, not because you have to write them down, but you have to think in this way in order to understand and don't make any mistakes. But try to learn it, do it faster. Now I go to part B. So part B, I want to do the same thing. So I want to take the derivative of my function. My function is the difference of two parts, so I have to do more or less the same thing as I did before. But before doing that, I want to write it in appropriate form. So let me write it in this form. Ax squared is good enough, but the other one should be interpreted as 4 times 1 over x. Then I want to differentiate. So this becomes the derivative of the first part according to the last row of the formula sheet here, minus the derivative of the second part. But now a is considered to be a constant. I pull it out and I just differentiate from x squared. Again, the same story, 4 is a constant. I pull it out and I differentiate 1 over x. But now the derivative of x squared is simply 2x. The derivative of 1 over x, you also have it this row in the table. So it becomes minus 1 over x squared. So it becomes minus 4 times minus 1 over x squared. But be careful, you have to write the simplified version there. So a times 2x becomes 2ax, minus 4 times minus 1 plus 4 over x squared. And this is the answer that you are supposed to provide there. 2ax plus 4 over x squared. And to be honest, I want you to know that how you derive that for this part of the problem is not important. What you write here is important. So you have to be extremely careful not to make even one single mistake there, because then the whole point will be gone. Okay, now this question. This question, apparently it doesn't fit to any one of the rows in this table, but you need to know that is related to the exponential function, okay, because here the base is a constant and the exponent is variable. Whenever you have this, this is an exponential function, and during the lesson we learned that these are exponential functions. So I have to compare this one with this one. Okay, but that's not exactly this, because here I have only one single x and I have this number a, and I do not have this 1 in my formula. But that is very simple. If you just remind yourself about the formula in NpMa3c, you know what to do, yes? So the answer becomes f of x equals to, I bring this up and make the exponent positive, but then I would write it as 3 to the power 2 to the power of x, then it becomes 9 to the power of x. Now this becomes comparable to this formula by giving the role of a to 9. So the derivative simply becomes, I just read the formula. It is a to power x, so it means the function repeats itself, but I have to multiply by the natural logarithm of the base here. So the derivative becomes 9 to the x, but multiplied by ln of 9. And that is what I have to provide here, 9 to the x times ln of 9. I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.